When you are working on your What Causes the Seasons worksheet, some of the work is going to be something that needs to be done in class, and some of it is going to be guided by students who are outside of class. So on the day we worked on this, we did work on it all together. So those students who were in class needed to have their graphing paper, which you should see on your online copy. But because it's just going to be too hard for you to draw those shapes on your paper, you don't have to worry about that, and that's why we work together. So they should have a flashlight, and with their flashlight, they're going to hold it at a straight angle pointing down, and they're going to circle this small area that this makes. So if I just circle this outline, and I know it's hard for you to see on camera, but I make a circle that's about this big. Okay. And so I'm going to color that in. That's going to be area 1. Now, area 1 has my flashlight at a direct angle pointing straight down. And then I can go back and I can count how many boxes I've colored for area 1. So that looks like it's about 6, 7, maybe 8 or so boxes. It doesn't have to be perfect, but if you see I have 1, 2, 3, 4, 5, 6 full boxes. These 3 could probably be combined to make 7, and then those are maybe about 8. So 8, 9, something like that. On the back side, I've got I flashlight. For box number 1, I'm going to go ahead and write 8. The next step is to take my flashlight and hold it at a slight angle. So again, I'm going to hold it up 2 centimeters, and I'm going to tilt it at a small angle, making sure that it's still 2 centimeters off of my paper. I'm going to take a different color. This one red. And trace this area. And that's going to make an area that's a little bit bigger. You can see right here, I'll color it in real quick. But again, I'm just going to color that in and count up all of those squares. Count how many squares were colored red. So this is what my shape looks like for area 2. So if I count those, I've got about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We'll say about 29. So for area 2, it has an area of 29. So now I'm going to hold my flashlight at a more drastic angle. So again, I want to make sure it's still 2 centimeters above the table. And then I'm going to circle that area that is lit up. And I'll color that, make it orange. That area is going to be about 3. About 66 boxes. So I'll keep coloring this in real quick, show you what that looks like. And then on the back of our paper, that's about area 3. And I counted 66 boxes. So we have 8, 29, and 66. So together we'll answer these questions. For number 1, it says, did the amount of light coming out of the flashlight ever change? So if I take my flashlight and I turn it on, does it matter where I point it? Or does any more or less light come out just by turning it in different directions? No. The same amount of energy, the same amount of light is going to come out of this flashlight, whether I point it up, down, swirl it around, the same amount of light comes out. So, did the amount of light coming out of the flashlight ever change? No, it did not. So with my pencil, I'm going to say the amount of light coming out of the flashlight did not change. Okay, and if you need to rewind this video for a second to get that answer written down, you can do so. The next question says, which area had the most concentrated light? Now, if you think about the word concentrated, you can look it up if you don't know what it means. Or if you think about if a teacher says, okay, I need you to make sure that you concentrate. What are they saying to you? They're asking you to focus, right? To focus. So if I take my flashlight and I move it closer or further away, which one looks like my light is more focused? Our light is going to be more concentrated or more focused when we're closer to the paper or when it's making that one bright spot instead of being what looks like spread out across a bigger area. So if you think about it, if the amount of energy does not change when it leaves the flashlight, all of the energy is either going to be in 8 squares, 29 squares, or divided by 66 squares. So if I have all of the energy put in 8 squares, that's going to be a lot of energy per square versus my energy divided out by 66 squares. So this is where it's spread out and it's less concentrated. So 8, or area 1, is going to be where I have my direct light. That gives me that concentrated energy. So for number 2, area 1 had the most concentrated energy or concentrated light. And how did I know that? Well, again, if I have the same amount of energy coming out, but it's over a smaller area, that means all my energy hits one spot and all that energy goes into that spot. And it's going to just be focused in one area. And when that's the case, that's like we talked about, if you hit your brother or sister, if I hit them square in one spot, that spot's going to hurt. But if I hit them at an angle and it spreads across a bigger space, bigger area, then it's not going to hurt as much. So I know this. So how do you know? I know this because all of the energy hit one small area. The amount of energy didn't change, but the space that it took up did change. For number 3, what happened to the area size as the angle of the flashlight increased? So when I took my flashlight straight up and down, my area was only 8. And when I tilted it to the side, it fanned all across that page and my area ended up being 66 squares or 66 units. So what happened as we increased the angle of the flashlight? When we increased the angle of the flashlight, the energy spread out across the page, or the light spread out across the page. And for number 4, why did we do this activity? And it even tells you, look at the title and activity of the activity and reread the instructions. So we talked about these pieces up here. We said that the Earth's axis is on a tilt of 23.5 degrees. The Earth is also a sphere shape or spherical shape, which means it's a 3D circle. Because the Earth is a spherical shape, some of the sun's rays hit the Earth directly, while others hit the curved portions of the angle. So again, that's where if you hit your sister, your brother in the arm, or your cousin, don't do it, but if you did, if you hit them solidly in the arm and your hand stops, if you hit straight on, all that energy goes into that one spot. But if you hit on the side or at an angle, then it's going to bounce off, spread out, and kind of ricochet, you can say. So reread this and use this information to answer number 4. The bottom is just some interesting information as well. We do have a student who was born on February 29th, which is our leap day that only occurs once every 4 years, and that's Kira. So woohoo! It's exciting to be able to talk to her about it. I've never known someone who was born on February 29th. So anyway, finish this, and if you are doing a digital copy, you need to turn it in online. If you have a paper copy, you need to turn it in when you come back to school. And email me if you have any questions or rewatch the video because I just went through all of it.